Hello, welcome to the discussion video for Taylor and Maclaurin series. In this video, we will answer several exercises on this topic. And before we proceed, please make sure na napanood nyo na yung lecture video for this topic para familiar na kayo sa mga concept and techniques na gagamitin natin sa ating exercises. Okay? So here is a list of the exercises that we will answer in this video. So hahatiin natin yung video into two parts. So for the first part, we will answer items 1 to 4. And for the second part, we will answer items 5 to 7. Kung gusto nyong subukan munang sagutan yung exercises na ito on your own, you can do that first, okay? Para rin makapag-practice kayo. And then kapag ready na kayo na makita yung solution, balik na lang kayo sa video na ito. Okay? Okay, let's begin. So for our first example, we want to determine the Taylor series for f of x equals 1 over x plus 2 centered at a equals 1. First, recall that given an infinitely differentiable function f, we can associate to f this power series. So ito actually yung tinatawag natin na Taylor series for f about a. Okay? So kung i-examine natin yung ating series, observe that ano pa ba yung mga unknowns dito. Okay? So si x and si n, wala tayong problema dyan kasi yan ay variables. Okay? So hindi natin kailangan hanapin yung values nila. Si a, usually given yan sa problem. So find the Taylor series for f centered at a equals something. So given to sa problem. Okay? So ano na lang yung unknown dito? So etong term na ito. Tama? So when we're given a function, tapos kailangan nating hanapin yung Taylor series for this function, ang ginagawa natin usually ay hinahanap muna natin yung expression na ito. Okay? How do we do that? Well, we're given a function. So to get the general form of the nth derivative of f, pwede tayong mag-differentiate dito. Okay? So usually, i-differentiate natin once, twice, thrice, and so on, hanggang eventually, makikita na natin yung pattern dun sa mga derivatives. So doing that in this example, observe that if we let f of x be equal to this. So, sinulat lang natin siya in this form para mas madaling mag-differentiate. And then f prime is equal to this. Right? And then f double prime is equal to this. F triple prime is equal to this. And kapag tinuloy nyo yan, mas madaling makita yung pattern dito. Which is, the nth derivative of f with respect to x is always of this form. Okay? So ngayon, nakahanap tayo ng general form for our nth derivative of f. Pero doon sa ating formula, kung babalik tayo dito, ang gusto natin ay evaluated siya doon sa center. So doing that, evaluating this at x equals 1, we get this expression. Okay? So ngayon, pwede na natin gamitin yung ating formula to find the Taylor series for this function. So we have this. Okay? So dito, sinubstitute lang natin ito. Dito, no? So we get this. Observe that pwede pa nating isimplify ito. Right? By canceling n factorial sa numerator and denominator. And we can write this. In-express natin ito in this form para mas madaling makita that this is a geometric series with common ratio negative of x minus 1 over 3. Okay? And then you can verify that the interval of convergence of this series is the open interval from negative 2 to positive 4. Okay? For our next example, we want to determine the Maclaurin series of f of x equals the hyperbolic sine of 2x. Now, recall that the Maclaurin series for f is just the Taylor series for f centered at 0. So we have this formula. Okay? And then, to find the Maclaurin series for this function, so i-follow lang natin yung ginawa natin sa previous example. So first, hanapin muna natin yung expression na ito, and then we can use this formula. Okay? Observe that kapag dinifferentiate natin ito continuously, so f prime is equal to 2 cos 2x, f double prime is equal to 2 squared sinh 2x, and so on. Eventually, mapapansin natin na yung pattern ng nth derivative ni f ay equal dito. So kapag n is odd, we have 2 raised to n cos of 2x. And when n is even, we have 2 raised to n sinh of 2x. Okay? And then, again, balik tayo sa formula. Ang gusto natin ay evaluate ito sa 0, okay, sa center. Doing that, we have this, okay? And then simplifying this, recall that cos of 0 is equal to 1. So this just becomes 2 raised to n. This is true when n is odd. And then this becomes 0 since sinh of 0 is 0. Okay? So ngayon, para mahanap yung coefficients ng ating Maclaurin series, so ito yun, no, yung coefficients niya, i-divide lang natin yung nakuha natin dito by n factorial. Okay? Doing that, we get this. Okay? Now, the Maclaurin series for f of x equals sinh of 2x is given by this formula. And then, pag sinubstitute natin yung mga nakuha natin for this is Cn, no? Cn, which is this, right? Itong dalawang ito. So, kapag sinubstitute natin, ito yung magiging expansion ng ating series. Okay? So, kapag n is even, ang coefficient natin ay 0, so yung buong term ay magiging 0. So, this is for n equals 0, n equals 2, n equals 4, and so on. And then kapag n is odd, our coefficient is of the form 2 raised to n over n factorial. Evident yun dito. So here, when n is 1, we have 2 raised to 1 over 1 factorial. Here, when n is 3, we have 2 cubed over 3 factorial, and so on. Okay? So ngayon, gusto nating i-express ito as some Maclaurin series. Okay? Observe that yung mga non-zero terms natin ay yung terms such that yung exponent ni x ay odd, no? So to generalize this, we can write this as this. Okay? Okay. And then recall that from the lecture video, actually binigyan na tayo ng formula for the Maclaurin series of some functions. So isa doon yung sinh of x, tama? Which is, the Maclaurin series for sinh of x is given by this. Okay? So pwede rin natin gamitin ito actually. Mas mabilis nga siya. Pero ginawa pa rin natin yung process na to para mas maintindihan natin yung process at para rin masanay kayo. Okay? So try natin ito kapag ginamit natin yung formula directly. So here, we want to find the Maclaurin series of sinh of 2x. So yung x dito, papalitan lang natin ng 2x, pati dito sa right-hand side, which is this. And then simplifying this, we get this series, which is precisely what we got here. Okay? And then next, you want to use the Maclaurin series of the sine function to show that this equality holds. Okay? So recall natin from example 6 of the lecture slides, we were able to establish that the sine function is equal to its Maclaurin series. Okay? So ito yung Maclaurin series ng sine function. Okay? So ngayon, pwede natin gamitin yung result na ito to show that this equality holds. Okay, so to do that, we have this. Note that using this, we can write sine of x squared as the summation from n equals 0 to positive infinity of negative 1 over 2n plus 1 factorial. And then yung x natin dito ay magiging x squared. So we have x squared raised to 2n plus 1. And then simplifying this, we get x raised to 4n plus 2. And then now, integrating, we get this. If we evaluate this at x equals 1 and x equals 0, the resulting series is given by this. Note that this is precisely what we want to show. For the fourth example, we want to find the Maclaurin series of x squared times e to the negative x and use it to show that this equality holds. So first, hanapin muna natin yung Maclaurin series for x squared e to the negative x. Now recall from example 3 of the lecture slides that e to the x is equal to its Maclaurin series, which is given by the summation from n equals 0 to positive infinity of x raised to n over n factorial. Okay? So using this, pwede nating hanapin yung Maclaurin series for this. So ang gagawin lang natin, yung x dito, gagawin natin negative x. So ganun din yung gagawin natin sa right-hand side. And then we multiply both sides by x squared. Okay? So doing that, we get this Maclaurin series for x squared e to the negative x. So now, we will use this to show that this equality holds. Kung titignan natin yung ating problem, kung ano yung gusto nating ipakita, okay? Observe that kapag kinompare natin siya dito, sana magkaroon tayo ng idea, no? Na kailangan natin i-differentiate ito to get this series. Kasi meron tayong factor na n plus 2 sa ating coefficient, no? So if we differentiate both sides of this equation, una muna yung left-hand side, differentiating this with respect to x, we get this. And then differentiating the series on the right-hand side, we get this. Again, pag nagde-differentiate tayo, we're only differentiating the terms containing the variable. So dito, differentiate lang natin yung x raised to n plus 2. Ang derivative nito ay n plus 2 times x raised to n plus 1. And then dito, hindi natin kailangan mag-reindex kasi when n is 0, positive pa rin or non-negative pa rin yung ating exponent for x. Okay? And then, observe that, pwede nating i-combine itong negative 1 raised to n, tsaka yung x raised to n plus 1. Pero to do that, dapat pareho muna sila ng exponent. So, para maging n plus 1 ito, we can multiply negative 1 times negative 1. Tama? Yung isang negative 1, mapupunta dito. Yung isa, dito lang siya. Okay? So, we get this. Okay? And then, dahil pareho na yung exponents nito, pinagsama natin sila. So, we have negative x raised to n plus 1. Okay? Ito yung isang negative. Okay? Hence, equating the two, we get this. Okay? So now, if we let x be equal to 2, then the left-hand side becomes 4e raised to negative 2 minus 4e raised to negative 2. So this becomes 0. And here, we get this series of constant terms. Okay? So simplifying the left-hand side, this becomes 0. And then simplifying the right-hand side, we get this. So dito nag-reindex tayo kasi kung babalikan natin yung problem, nagsa-start yung summation natin dito sa 1. Okay? Okay, and then simplifying this, we get this. Dito we have negative 2 times negative 2, which is 4. And then we have this. Okay? And then transposing this to the other side, we get this result. Okay? Which is exactly what we want to show here. Okay? I hope nasusundan ninyo.